All right, hi. I'm Eric Roberts, and I'm here to talk to you all about how you can use software design patterns to put your Rails app on a diet and make your tests run really, really fast. Jokes aside, we will be telling you about some design patterns, not so much making your tests run fast. But we're here to talk about domain-driven design, hexagonal architecture, and Rails. I'm Eric Roberts. I'm a software developer, and I work at a company in Waterloo, Ontario, Canada, called Boltmade. I met Declan when we worked together at Printchomp. Before that, I was a front-end developer for a number of years, and I'd worked around Rails applications, but mostly at the view layer, until Declan dragged me kicking and screaming into back-end development and made me care about stuff like we're talking about today. And this is the biggest crowd I've ever presented in front of, so if you'll excuse me, I need to take a picture and email my mom.
Okay. Hi, everybody. Real pleasure to be here. My name is Declan. I'm the co-founder of a company called Printchomp, and my story is about 2 years ago, we had an opportunity to launch Printchomp, and I was looking at technologies, and I decided that Ruby on Rails was really the best platform for us. The only challenge was that neither me nor anybody on my team knew Ruby nor Rails. So it was a kind of a brave, maybe, decision, but it's one that I don't regret. And one of the things that drew me to the community was the fact that, into the platform, was the community around sharing, around the openness of sharing code, and also a lot about the test focus, which has been pretty important to me. But the cool part, I think, about it was we intentionally took on a lot of technical debt because I knew that I would not know enough about our domain. It was a new domain for me, printing, and I also did not know enough about Ruby. I did not know enough about Rails. So very intentionally decided to do the best that we could, knowing that we would end up very likely with a pretty heaping mound of technical debt. And that turned out to be true. And has anyone had that experience? I don't know. Yeah. So, but recently we had an opportunity to build an API, and that was really exciting for me. And I know there are going to be some other talks about APIs here later. And I realized that I had two kind of competing things that could come together. The first was I had logic in our application that I needed to share in our API. How was I going to do that? And all of our code was sprinkled through various bits of our controller and model logic. Secondly, I wanted a mechanism to have a strategy for eliminating the technical debt. And what I turned to was domain-driven design and hexagonal architectures, and I want to share what we've learned along the way of doing that and where we're going. So I hope you're able to learn something from what we've done. And yeah.
That's great, Declan, but what are they going to get out of it?
Here's a good idea. Have a point. It makes it so much more interesting for the listener.
Well, that was from Sandy Metz. She said, if you're going to have a talk, you should really have a point. And I think Steve Martin said it pretty funnily. And I guess our number one point is that there is complexity in the software that we build. There's complexities in the problems that we're solving. And we need to embrace that complexity and embrace it in such a way that we tackle it and deal with it head on. And by doing that, then we end up having more joy and fun in our work because it's not just about getting this functional piece to work. It's about really trying to understand our domain and model it and express that in our code and make our code as expressive as possible. And the second thing that I really realized was I knew that our code was a mess, and I knew some point refactorings that we could do, but I didn't know how to what did the end look like? If it was refactored significantly, what would it look like? What would the shape look like? What would the namespaces be? What would the classes be doing, et cetera? And domain-driven design and hexagonal architecture helped me envision and share with my team what it might look like. The third thing that we would like you to take away from this talk is that there's a lot more to just being a Rails developer. The ideas and patterns, if you will, that we're talking about some of them have been written by some of the people that DHH had in his slide deck, including James Coplain. But a lot of those patterns have been around for a long time. So those patterns and those ideas and those practices will serve you well beyond Rails. They would work in a Node application. They could work in a desktop application. They can work in a wide variety of areas. So by getting some familiarity with these concepts, you're able to transfer those skills to things beyond Rails. And so I want to ask Eric just to walk us through kind of some of the pain that we had with our initial Rails development and see if it resonates with you.
All right. So everyone knows what this is. It's a Rails folder structure. And it's really great when you get started with Rails. You have these folders. Okay, logically, my things fall into these areas. Controllers, models, and views are really what we're focusing on right now. But if the responsibility of your code doesn't start with M, V, or C, what do you do then? And we found it kind of goes like this. You have these areas of responsibility, and you have something that doesn't really fit, and you don't know where it goes, so you just put it on somewhere, and things get a little bigger. And continuing on, you keep doing this, things get bigger. And finally, like, the line between all of these things is blurred. You don't know what's what. It's hard to extract reusable parts from all of this because the responsibilities are split across all these things. And you kind of end up with methods like this. This is one method. It starts on the left and ends on the right. It's about 90 lines. It's not from Printchomp. It's from another project that I've worked on. And it's about setting, it doesn't really matter what it does. The point is it's ugly, and it is actually about setting prices on properties and the date ranges that are available. So I have a question. We need to add sales tax to the prices. Anybody care to take on that refactoring? It's pretty horrible. But nobody sits down and says, I'm going to write a 90-line method today that does property prices with date ranges. The initial spec was probably something a lot simpler. And because it's in that spot now, the next person who comes and looks at that method and goes, oh, okay, well, if I just type this a little bit more, it'll do that now. And this was a little bit of a train wreck. At some point, the people working on this, including myself, probably should have realized, 45 lines might have been the time to split it up, maybe 20, maybe less. But this is nonetheless what we ended up with. Or you end up with Rube Goldberg machines for sharpening pencils. So there's a lot of well-known patterns that can help you out with this. Has anyone read this blog post? Yeah. Anybody use any of the patterns in them? Yeah. They're pretty great, right? We use a lot of them, and we're going to tell you about some of them here. But the one thing, you've extracted all of these things into small responsibilities. Your models, your controllers, and your views, they're all small again. But, okay, so what? I have a bunch of little objects that they all know too much about each other. They don't fit into any logical structure. How does this all fit together? You've made an awesome first step in that you have small little pieces that you can use. But where do you go from there? And we think that looks kind of like this. We think that your domain concepts, services, entities should be in the middle, and everything else is outside. Your database is an extra concern. Your views are an extra concern. The web, when you're designing the API, as Declan talked about a little bit, it's an extra concern. So you can really focus in on the middle and what your application actually does. And I'm going to let Declan talk a little bit more about that.
Has anyone heard of domain-driven design? Oh, quite a few people. Awesome. How many people have actually intentionally used it and have worked with it? So a number. So cool. And it can be quite daunting. If you could. And this book by Eric Evans is kind of what kicked it off. And this book was, I think, written in 2005. And it is a really, really great book, but it is actually quite difficult to read. But I think it might be the only technical book I've read twice. And that's partly because it was really good, and partly because it was rather difficult to get through some of it. Did anyone else read this book and have a similar experience? Like, it's really great stuff, and you kind of read it and you go, wow, what does that mean to me, right? And at the end, we'll be posting our deck, and we'll have some references to other material that I've actually found to be a bit more addressable or a little more consumable. But what Eric Evans talked about was really tackling complexity, and And he talks about the critical complexity is really understanding the domain. What are the business rules that take place inside our systems? If we're going to add sales tax, what are the business rules for that sales tax? What are the rules around who can buy what? And by putting those inside and thinking them as the domain of our system, then we're able to have our outside layers just be, if you will, relatively thin facades, which allows us to reuse that logic across APIs, across other applications. We don't have to duplicate all of those business rules. And the way that he proposes to do that is through ubiquitous language. And this is a picture of the Tower of Babel. And if anybody knows the story, it's where everyone in the world was speaking a different language. And I once worked on a project that was a financial transaction processing system. And when I inherited it, the guy who preceded me was a model train aficionado. So he had the idea of model trains. So every transaction was like a car, and the payment engines were train tracks. And he had all of these metaphors around transaction processing and trains, and it was written in Java. So when I was asked to add a new feature or fix a bug, I had to understand the business domain, and then I had to kind of understand how did that translate into train speak, and then I had to go look at the Java code to figure it all out, right? So the coding was easy. The hard part was really trying to understand what was being asked and how did the code express that, right? And that's what Eric Evans is talking about with ubiquitous language. We want to have the language that we speak with domain experts should be readable in the code. If I'm a customer and I can purchase a product, there should be a class called customer, there should be a class called product, and there should be a verb in there that's somewhere that says purchase, etc. So that there's minimal translation between the domain expert's language and the language that my code is written. And Ruby gives us a great opportunity to do that is much more difficult in other more statically typed languages. So that's kind of the key thing to take away from domain-driven design, is to try to have your concepts expressed in code that are meaningful in the words that people use. If they use the word customer, you should have a customer class. If they use the word user, you should have a user class, etc. But beyond that, he also has some kind of key, I dare not say it, patterns? I'm almost nervous now to say it. But let me be clear. This isn't science. It's not, right? Because these patterns were not dreamed up in academia ivory towers. These patterns that we talk about were empirically derived from people intentionally doing what we do, which is write code every day, intentionally thinking about how do those things fit together, and what is the essence of what I'm doing. And can I extract that into words that I can use to communicate with other people? The beauty of patterns is I can talk about a value object, and if you know what a value object is and I know what a value object is, we can have a much richer conversation than, oh, I have to have an object whose identity is defined by the state of its attributes, and that we can have a much richer conversation.
You might say ubiquitous language.
Yeah. So we're going to touch a little bit on some of these patterns, but the idea is that these are not academic ivory tower concepts. These are empirically driven from people who've worked in the field. And if we're going to be successful as an organization, while I fully agree that we need to go out and write code and we need to read code, I totally think that's true. But we also have to have more effective ways of communicating knowledge so that we're not all learning the same things from each other over and over. We can learn more easily from each other. And that's what these patterns are. And the next kind of piece that we're going to talk about is hexagonal architectures, and it's more than just that. And I think we've alluded it to a little bit. It's really the idea of you're going to have this core domain in the middle, and inside your core, surrounding your outside core, are going to be some application level code that expresses the rules of your application. And I would draw it slightly differently, perhaps, but and then we have adapters on the outside that adapt that code to web calls or database calls or SMTP, or in my case, APIs. And so that's the way that we want you to. That's the way that we are starting to approach the work at Printchomp, is thinking about it in those constructs. And now we want to jump to some specific patterns and show you some real code that actually brings these to life. So Eric, do you want to talk about the form object?
Sure. Unfortunately, I can't tell you what your domain is or necessarily what goes in the middle of that hexagon, but I can give you some ways to keep other things out of that hexagon that you don't need to be concerned with. One thing that I've been doing lately is a form object. One of the really cool things, if you run Rails scaffold, some model name, you get a form that you submit, creates the record, edits the record, and that's pretty great. But how do you do that when you don't have a direct one-to-one mapping with an active model record? So instead of instantiating an active model record, I've taken to instantiating, I'm going to call it a form object. There's a lot of names for a lot of different things, but this is what I've been calling it. So here's the actual thing that I was building. On the left-hand side, you see that you select a ticket price. On the right-hand side, your name, email address, and your payment details. And this is actually 2 active record models in my database. The passengers over there on the right, you can add a passenger and keep adding it. And if you've ever worked with nested attributes, you probably know it's not always that fun. So this is not using nested attributes. It's done like this. I have a class ticket form that includes active model, which is how I get nice things like that magic initialize method and validators. And the passengers method, if I don't have any, returns me a passenger new. That's how it puts the name and email address for that first passenger. And then tickets I get out of this by taking my passengers and mapping them into new objects. In the controller, it looks a little bit like this. So you just pass your params off into that. You get it back out, and you have tickets. And so instead of if ticket.save, I do if ticket form valid and ticket charger charges successfully, then we've had successful. And ticket charger takes care of saving my tickets and knowing that there was because there's only one charge for all the tickets, right? You're paying all at once. No point to split that out. So that's a really useful thing that I've found to help when my mappings aren't just totally, I don't want to just take a record out of the database, put it in, or update it. And now Declan's going to tell you a little bit about request objects.
Yeah. I'm just curious, has anyone used a form object or something like that? So quite a few people. Cool. Has anyone used something called a request object? Sort of. I was hoping that I invented this, so maybe I haven't. I don't know. Okay. But request object is now in, think of an API is we're trying to have a similar behavior to the form object, except we're trying to take complexity out of our controllers and out of our models and put them into more, to simplify our systems. So the idea with the request object is that we're going to pull that code out and put it into the controller. And now the request object is going to receive the request. And the code looks sort of like this, right? I've done this slightly differently than Eric's way in terms of the kind of the core of the class. The core of this class is using a gem called Vertis, which does something similar to active model, except this allows you to basically have a plain old Ruby object. And the cool part is that, or I think it's cool, is you can declare attributes like this. So I have actually in my domain layer, I have something called a customer and a billing and a shipping. And if somebody supplies me those 3 things, then I can complete an order in my system. There are a couple of pieces missing here, but we wanted to fit it on a slide. But that's basically it, and we have the validation. And the cool part about this is that when a request comes in, I just put in a before loop in the controller that has a before filter that just basically instantiates the request object using some reflection to figure out what is the controller and what is the action being asked, inferring the request class, instantiating it, and then just passing it what used to be the params hash. But now it's actually a rich object that I can have validations on it, etc. So the net effect of this is that why would I bother doing this, right? Well, now the complexity around validating the request is at the boundary of my system. That doesn't need to leak in to the rest of my system. It's almost like does anybody use, at the beginning of your methods, you want to put the guard clauses to catch the exceptions coming in at the beginning of your method so that the rest of your method is simpler? This is doing the same thing, except it's doing it at a higher level of abstraction at the API request level. And this has worked out really well for us, so I quite like that one. Yeah.
Great. Service objects are another one that we've been using. I think DHH actually had one in his presentation. I'll give you a hint, he didn't like it. He used one, it's something instantiated by the controller. We've been looking at controllers as a little bit of just like okay, I've received this thing, pass it off to somebody else, and then do something with the result. So we want to keep out that procedural code from our controllers, and service objects are one way you can do that. Using a order service to create orders, we've encapsulated all of the logic about how to create an order in this one area. So if you want to, you could use it from somewhere else, right? You don't have to hit a controller action to create an order. It's reusable and extendable. And it has Declan's magic repository object in there that we'll get to in a bit. And the controller, again, it's very simple. Do this thing. On success, do this. On failure, do this. So those are a few of the patterns that we've been using to help us with this. So now what? What's the elephant in the room? Anybody?
How do you get them into Rails? Yeah.
Yeah.
Well,
that's the one we were thinking of.
That's an active record. Yeah, and how you get into Rails. Yes, there are some interesting challenges around that. But I'm going to flip you back to the architecture slide and just point out that you see what's happened here is that we're trying to view the application pieces of our solution here being really on the perimeter of our core system, and the core system composed of services that may be servicing API or application requests. We have some services that may be invariant across any call, and those would be at the very center. And we have things called entities, which are on the inside. And the key part that we haven't talked about, which actually I'm finding the most difficult part in this, is this repository, which is the bottom, which is the R in the bottom right-hand corner. And its job is to talk to the active record model, which is in the green, and create an entity object, which is the blue object. And how does that actually work? So I'm going to show you a bit of code, and this is the first time I've shown my Ruby code in public. So please be kind. And there are probably way better ways to do this, but this is the repository that there are some other methods here, but I just wanted to fit on what happened. Show you the simple ones. So this is what a save looks like. So the save takes a domain object, and it converts it through something called a mapper, which maps the domain object onto a active record object, which is called a record here. Then it calls record.save, assigns the ID, and returns the response. So that's pretty straightforward. All that's really happened is, and I've really tried to do this, and so far I've been able to, I don't want to have domain.save. I want to have repository.save domain, so that there's no persistence that's leaking into my domain objects. Persistence I want to be a secondary concern to what that object is really doing. And so far, it's worked, although sometimes it's caused me some difficulty. The method missing down there is kind of cool. At least I think it's cool. And what it's doing is it's introducing a scope object, which I'll show you in a well, here's the scope object. That's okay. And it creates a scope object. And this was the trickiest code that I had to write. But what it does, the end result of this code is that it allows you to call any of your active record find methods or your scopes and chain them together. So you can now use, so in other words, with this logic, wherever you had like active record dot, find where ID greater than 122 is activated and so on. Wherever you might have a chain like that, you can still use that chain now because of this scope class with your domain objects, except instead of getting back your active record object, you're getting back its domain representation. Does that make sense? Yeah? Okay, and then the mapper is what maps them across, right? And in some cases, the mapping is like really, really simple. What's the next slide here? Yeah, there it is right there. So the mapper, because of the way Vertis works and the way Active Record works with attributes, you can almost just instantiate one from the other, just passing the attributes back and forth. So it's actually quite easy, except when it's not easy. And then what I'm doing now is just wherever I have something that doesn't fit this model, I just subclass this mapper with a custom mapper and override those methods, more or less. And that's the part that I think would be more expressive ways to do that mapping, and that's what I'm starting to look at now. But so far, this has actually worked pretty well. And it's allowed me to completely separate the way I think about persistence from the way I think about my domain objects. So before I had this, we used to have an order class, and I kid you not, and I'm a Rails noob, so you can shoot me, but it had 48 attributes in the active record model, right? That is now represented by about 8 classes that separate out all of the different aspects of the order, like the shipping, the billing, et cetera, et cetera. But I think this mapping is one of the more challenging parts. And then finally, then you quickly run into things like, oh, well, what happens if I get the record, I save it, then I save it again. I have to be able to keep track that I've saved it once already so that I don't have multiple copies around, and this is an identity map. In fact, an identity map was built into Rails. And I think it might, I don't work in Rails 4, but I think it might be taken out or changed slightly. But actually, on the next slide, I'll show you what the identity map looks like. And this actually I stole from Rails and made it a bit simpler. But all it's doing is just making sure that there's a unique instance on a per API request call for each entity object. So that I can, and it actually serves as a really cheap cache, but that's not what its intent is. So that's kind of where I'm going now. Is most of those service object, form object requests, those all kind of work well for us, and I'm now looking at what would a repository pattern look like fleshed out, and that is by far the most challenging piece. I heard a question about where you put things. You can really just put them anywhere. That's the thing. Like Rails just seems to be. There's a part that I just felt constrained. Like Rails didn't give me any guidance on where do I put a service object. Well, you can really put it anywhere you like. You could put it on the auto load path, or you can put it where Rails might expect to see it. But you can just create a services directory and put your service objects there. Rails will find it. It's not hard, but Rails doesn't really kind of tell you what to do. So it doesn't make it easy to do these, to think of it, but it's not hard. And but that's where we're going with that, and we'll give you a link to I've started a Git repo where I plan to share some of these ideas, and if you're interested in sharing ideas with us on that, we'll happy to talk to you or join us on the Git repo.
Right. So what's the point again? At the start, we had these 3 things. Embrace complexity. Getting the solution to work is only part of the fun, right? It's your first draft, as DHH said, talking about writing. You do it over and over. And getting things to work, that 90-line method I showed earlier, that worked. But does anyone want to go back and use that again? It's no fun to revisit unless you're improving it, which I did do eventually, and now it's much nicer to work with. That's fun. At least we think that's fun. Getting beyond the problem and getting it to a level where we actually don't mind going into our code, extending things, and changing things. And we do that by breaking them up into the smaller parts with the patterns that we've talked about. Knowing where you're going. In Alice in Wonderland, to paraphrase, they said, if you don't know where you're going, any road will take you there. We think it's important to know where you're going and pick a road that you think will take you there. It doesn't have to be our road. These are things that helped us, and we think they're good ideas. But it's not going to solve every problem for everyone. These aren't rules, like Declan said. They're not science. You can't just take them and throw them on and expect that your code will magically get better by going on a diet. And be more than just a Rails developer. Not that it's bad to be a Rails developer, but these things apply across languages and stuff. Like, don't just learn Ruby. Learn beyond that. So as Declan mentioned, we have this GitHub that we set up, and right now it's just a README. We don't actually have the code in there yet. We'll likely put some of the code we showed today, especially the repository bits, but we'd love to continue the discussion via issues, pull requests, whatever. That would be awesome, and we'd love to talk to you about some of it throughout this week as well. Declan also mentioned we have reading. You'll be able to get these slides after, so I'm just going to gloss over them. These are a couple of the books that we've taken a look at to help us out with these things.
I think the crowd has spoken, and it's time to wrap up. If you want to come up and talk, have it answer your question. Thank you.